All right. So in this video clip, I'm going to show you, just revisit how we explore a new data source, PBI 97NK, the direct mail response data from a charity organization. So this is in tutorial note chapter 2. I'm looking at specifically page 28, subsection 2.4, exploring a data source. So we're going to create some charts and graphs. So let's dive into it. So let me switch to my Citrix environment. This is where we were. We now have a project being activated. Within that project, we have specified a new data source, and we opened up a new diagram. So let us take a look, close look at or explore what's in the new data source. Move your cursor on PBA97NK within the project panel, right click, and select the last option, Explore. And this is a Explorer window. I believe it appeared on your screen as well. And if you look closely at the bottom of this screen, we have the raw data set, multiple columns and multiple observations. Top right corner, it gives us summary statistics, um, minimum, maximum, mean. If I expand this a little bit, and even it shows a percentage of missing values. So if you remember this, the person's age, about a quarter of them, we had missing values. And gift average card, which is what is the amount of donation in the last 36 months. Again, in 18% of cases, we found missing values. So these are sort of red flags indicating that we should address this missing value problems. All right, so and on top left corner, the sample method. If you see top rather than random, please change to random. Fetch size, if it is something else like a default, please change it to max. By changing these, we basically force the enterprise miner to use every single observation in the data set when it computes all these summary statistics. So within this Explore window, we are going to first create a histogram on a person's age. So hit Actions button on the top left corner, select Plot, and third from the top, histogram. Next, and person's age appears on the top, and select its role from none to X, since we're going to plot the distribution on the x-axis. And that is pretty much it. So hit Finish button. And this is sort of default distribution. Using the default option, eMiner, Enterprise Miner produces this histogram. But you can see that there is an ample amount of room for beautification or improvement. One way one can do is increase the number of beans. To do that, right click anywhere on this screen and select Graph Properties. And number of X beans currently is set to 10. I'm going to change it to 87, which is our magic number. 87 came from the fact that the maximum, the highest, the oldest person in the data set happened to be 87. So we are using 87 as the number of beans. By doing so, we create one bar per age group, per each age. And let's click OK button. So, it doesn't really look beautified as much as you want it to be, but it's better. It gives you granular sort of view of age distribution. One thing we discussed in class, if you look at this left corner, we do have cases where age happen to be like a 0, 2, 4. So one conjecture for this is that someone else donated on behalf of those newborns or little ones. And if position your cursor right below the x-axis, you see the magnifying glass, and press the button, left click, and you can literally zoom in and zoom out. So that's one thing you can play with the histogram using those functions. And if you want to restore, after you zoom in, if you want to restore the original distribution, just select the yellow triangle on the right bottom corner, and you can restore the original graph. All right, so one thing we can also do here is, remember from the summary statistics, the input variable age has missing values. But this current histogram does not display missing values at all. So let us add, superimpose one bar indicating the frequency of missingness or missing values on this current graph. So right click and select graph properties and select show missing bin and select OK. And now we have one huge spike. As many as 2,407 cases, we have missing values in age variable. So it's a clear sign that we have to address this missing value issue in age variable. If we ignore it, it will definitely create some biases. It will mislead our results. So that's one thing you can find out by exploring the data, especially looking at or plotting histograms of continuous variables. What we are going to do is, while we keep this graph, I'm going to create another graph, actually pie chart of our target variable. So let's go back to Actions, Plot, and scroll all the way down and select Pie, and select Next. And our target outcome is target _ B, binary, and change its role to category, and finish. So as you quickly recall, in our data set, the data set is perfectly balanced. We have half 50% donors and the other 50% non-donors. So that's the reason why you see the perfectly balanced data set. And let us take a look the histogram we just created along with this pie chart. So I'm gonna select window and select tile. And let me shut down all the other tables and apply tile window one more time. So on the top of the screen you have pie chart, and on the bottom of the screen you have this histogram with one bin indicating the frequency of missing values in the age in the variable age. And the important thing is that these two graphs, they are connected. So if we make any changes on one graph, the changes are automatically applied to the other. So if I select a particular subgroup on this histogram, just selected folks who are older than 70 years old, and you can see the changes immediately being effect on the pie chart. So the shaded area indicating the volume of such cases. So within conditioning on the person's age is 60 or greater, if we look at the frequency of donors and non-donors, since the, the, the lower arc slightly thicker than the upper arc, we said there are more number of donors than non-donors within this specific age group. All right, so there are plenty of other things you can play with using within this explore option. I highly encourage you to do it to sort of noodle through the data set we have. But let me stop here and exit this explore window. And then I'm gonna make one permanent change using options tool from the menu bar and select preferences. So I'm gonna make changes. I'll change our sample method from top to random and fetch size from default to max. Meaning that whenever we compute summary statistics or whenever we create plots, we are going to use all observations in the data set. So that's the expected the effect or consequence of making these changes. And select OK. All right. If you look at the PDF file, I'm going to scroll all the way down to 2-56. We have done all of these, and I'm looking at 56 further down. Slightly up. So there is the exercise. So what I want you to do is replicate the steps we just followed using the Explorer option and using plot function, create a distribution of median income and try to look for if there is anything unusual about the distribution and think about the cause of that anomaly and think about how you can address that or fix it. So let me go back to my Citrix window and right click my data source and select Explore. Drink some water while I'm waiting. All right. Where were we? So let's go to Actions, Plot, and I'm going to create a histogram on median income. So median income, here it is. Put it on x-axis, finish. Again, I'm going to beautify it by increasing the number of beans. Grab properties. I'm going to just enter arbitrarily a big number, 100, and select OK. So what's unusual about this distribution? Well, if you look at this, at the left end, we have a spike. Again, this time, it indicates that we have as many as 2,357 cases where it says median income is 0, which does not make sense at all. So something happened. And if you recall correctly, these are the cases when a data entry person put a placeholder, the value of 0, when in fact, person's income information was missing. So what we are going to do is we're going to rectify this by changing 0 to missing. So let us do that. So let me close this Explore window. In order to conduct a sort of replacement on a particular variable, we have to drag our data source first, and I'm gonna add one node named replacement right next to it. So replacement is under Modify tab, third from the right, and add it. And I'm going to draw an arrow from data source to replacement node. Okay. And I select replacement node and examine its properties panel. So we have some properties panel, and we're going to make some changes. Firstly, I'm going to change the under the header of train, under the enable variables header. Since we deal with the median income, which is enable continuous, we're going to change the default limits method from standard deviation to none. And later on, we're going to define or specify our own rule. So let's change it to none. The second change, under the score header, replacement values, we're going to replace 0 with missing. So I'm going to select missing here. That's the second change. Third change, hit on the replacement editor under class variables. No, not the class. I mean, again, the median income is enable. So you should hit replacement editor right under enable variables header. Hit that one. And it will show you the interactive replacement enable filter, and in which we're gonna impose a replacement rule, so to speak. Third from the top, we have median income limit method. Let's change it to user specified. Literally, we're gonna specify it by ourselves, and we're gonna enter a arbitrarily lower limit, say 1, as long as it is greater than 1 and sufficiently small will work. So you can either enter 1 or even 0.1. So whenever the median income is less than 1, or 0.1, if you put 0.1 here, then the replacement function will kick in and replace that value with null or missing. So that's the anticipated effect by making these two changes. So I'm going to select OK, and let us run our set of nodes. So I'm going to right click replacement and select a running person and hit yes button one more time. We are almost there, so hang in there. So it's pulling data from the source, and we have a check mark, always a good sign. And now the replacement node is in action. All right, so we have 2 check marks. It's always a good sign. Select OK. And let's see the new change we just made. So to look at to access the data, so right under general header, we have exported data, means set of tables exported by this node, the output of this node. So hit that small box button. And select train, because we haven't separated or divided our data set into train, validation, test yet. So all the data belong to train data set. So select train and select explore. All right. So what we are going to look at is within this the data table, scroll all the way to the right, and the last column is the one which is just added, replaced median income. So, and the one before that is the original variable, median income. So if you look at the first row, the median income was 0, and that's the reason why the newly created the replacement median income variable takes null or missing. So whenever it is 0, now you have missing. All other cases, like 38,750, we have the exact same amount under the new variable. The change is being made only when the original variable is 0, because it is now replaced with missing. So our code, our node worked out the way we wanted. So we are good. So close all this. That's pretty much what we have done so far. And when we meet next week, we will continue to add more nodes, and we're gonna run our the first supervised data mining model, which is decision tree. So we're gonna run a decision tree using replaced data, modified data. Okay, with that, that's all I have for today. I hope you are able to follow through all the way up to here. And I will see you next time.